From one-dimensional motion, let's now graduate to two-dimensional motion. This is an example of two-dimensional motion. That means motion is happening in a plane. A lizard moving on the wall, that's a two-dimensional motion, okay? When you kick a football or throw a cricket ball from one person to the other person, and that person catches the ball, the plane joining the two people is the plane of motion now. So motion is still happening in a 2D plane itself. If I'm throwing the ball like this is my plane of motion, this two-dimensional plane with x-axis and y-axis. Now we are going to look at such motion. Such kind of motion on Earth are known as projectile motion. Projectile basically is any object that falls under gravity. Okay. So if you kick this ball, the only force acting on this is the gravitational force acting downwards. Is this a projectile motion then? So we have a big building. From the top of the building, I drop a ball downwards in this direction. Is this a projectile motion? An example of projectile motion? It is also an example of projectile motion. And this kind of motion, you know how to deal with it. You've already seen, yeah? In one-dimensional motion in class 9th or 10th, you've seen S is equal to ut minus half gt square is the equation for this. V equal to u minus gt and so on. V equal to u plus gt and v square minus u square is equal to 2gh. These are some of the equations of motion of this. But now, this was 1D projectile motion, already covered in one-dimensional kinematics. Now we are going to look at 2D motion, 2D projectile motion. Only for qualitative analysis sake, I'm going to tell you that this is nothing new for us. If we understand one-dimensional motion, we understand two-dimensional motion also. How? Let's take a look. Assume one observer standing somewhere here, the other observer on the top, or let's say lying down at the bottom, like this, okay? To this observer, to observer 1, the motion of this ball is very, very simple actually. It is a one-dimensional motion. To this person, the object feels like the football goes up, comes down. That's all this person can see. Similarly, this person, person 2, also only sees the ball moving in this horizontal direction. That's all he can see. He cannot perceive the height, okay? So this person is also looking at this ball and one-dimensional motion. This person is also looking at this. For him, it's one-dimensional motion under gravity. So let's say both of these people, they jot down the data. Where is the object? What is the x and y coordinate of this object at a given time? T1, T2, T3, and so on. This person also jots down a similar data. When they come together, they pool their data. They would know exactly everything about this motion, okay? So if we know how to deal with one-dimensional motion, we also know how to deal with two-dimensional motion. How to find the maximum height, how to find the range, you do not need to remember or memorize the formulae for this. If you know these three formulae, V equal to U plus AT, S equals UT plus half AT square, V square minus U square is equal to 2AS. 2D motion does not need anything else apart from these three formulas. Okay, for understanding. Of course, for faster calculation, if you remember the formula, that is better. Okay. So what did we learn? Two-dimensional motion is just one-dimensional motion 2 times. One horizontally, the other vertically. That's all. Okay.